Hi, my name is Mike Tisi, Systems Administrator for the James A. Gibson Library at Brock University, and I'm going to talk about the technical implementation of the library HPC cluster and why we chose to implement the way that we did. Because our initial goal was to use the library lab PCs as cluster nodes, keeping in mind that student use of those PCs takes priority, we wanted to avoid complex implementation that involved virtualization or multi-boot configuration that could result in reduced performance for the systems or configuration issues such as booting to the wrong operating system. After evaluating some options, we chose Microsoft HPC Pack as our preferred platform. And we did this because of it fits within our current infrastructure seamlessly. The head node runs on top of Windows Server, and the compute nodes, called workstation nodes, run on top of the Windows client platform, such as Windows 7 or 8. As an added benefit, there's both a web interface and a GUI interface that allows us to view or submit jobs to the cluster, in addition to command line interfaces which will allow us to automate the submission of the jobs. Most importantly, though, we chose HPC Pack because of the flexibility in which we can bring nodes either online or offline. Through the use of what's called node templates, we can define the criteria of when a node will be available to process jobs. The options that are available to us are manual activation, in which we would manually toggle a node as either online or offline, on a schedule, so defining the hours in which a node will become available, and available when idle, so for example after 15 minutes of inactivity. To go along with scheduling, the organization of nodes into node groups allows us to identify nodes based on hardware specs, physical location, etc., and it allows us to adjust settings such as those node templates according to those criteria. And so we can issue jobs to a particular group of nodes, effectively creating mini clusters. Now, I've spent a bit of time talking about node availability and scheduling, and that's because, at least initially, we see it as an immediate benefit to researchers. So being able to offload long-running tasks from personal or shared PCs and scaled out to 100+ nodes simultaneously. So where it may have taken an entire day to process a dataset of 24 files at an hour apiece, that can now be consolidated into 1 hour. Of course, being a high-performance computing platform, it does also support high-performance computing. So it does this through two technologies. It implements the Message Passing Interface, MPI, or Service-Oriented Architecture, SOA. For the purpose of this presentation, I'm not going to go into detail about those technologies, but I do think it's worthwhile mentioning that they are available. I will spend a little bit more time talking about MPI, though, since we are using it in a current project. We've been collaborating with the Cognitive and Affective Neuroscience Lab at Brock University to process EEG data. And this is a really exciting project to work on because it uses both serial and parallel jobs and really showcases what can be done with this system. So there's two steps in this process. The first part is that the EEG data is processed serially in GNU Octave, which is an open source alternative to MATLAB. In the second step, we take the output from Octave and we process that using software called Amica. And that Amica software generates the independent components from EEG data. And because both Amica and Microsoft HPC Pack support the message passing interface, we're able to distribute the processing to multiple cluster nodes. So where a typical instance of Amica may run for a couple hours on a single node, we've been able to reduce that to just over 20 minutes using the cluster. So if there are any technical or implementation questions, please feel free to contact me. My information will be available at the end of the presentation. Thank you.